Hi guys, Buildzoid here, and today we're going to be taking a look at SP ratings and some SP rating statistics for 12th gen Intel CPUs, mainly the 12900K and the 12600K. So first of all, what is the SP rating? Well, the SP rating is a feature that you get on high-end Asus motherboards, and it's basically just this number over here under prediction. You get SP81. And what the SP rating is a simplified representation of your CPU's vid table. So if we go over to AI features over here, you get also a more detailed breakdown of the SP ratings in here. So like my 12900K has a P-Core SP rating of 90, which is slightly below average, though at this point, well, we'll get to that. So based on this data I have, it's slightly below average, and an E-Core SP rating of 65, which I don't know if that's good or bad because I don't care about the E-Cores. So I've not bothered to, like, I do have bidding data for E-Core, or I have SP rating data for E-Cores. I've just not bothered to analyze it whatsoever because I couldn't care less about the E-Cores. Anyway, overall SP rating of 81 is overall just below average for a 12900K. Anyway, the way the SP rating is pretty much created is that Asus takes the vid table of your CPU, which you can see here, like we have P-Core P0 vid of 1.389, and then the E-Core vid of 1.234, and then the individual, like per core vids of 1.393 down to 1.383, and, you know, a few things in between, I guess. So you have these vid voltages. Asus basically does some math with these voltages, and that spits out an SP number. So that's how that works. And so you might be wondering, like, how is this useful? Why would this be a feature when it's literally just a alternative representation of a CPU's vid table? Well, the thing is, if you're a competitive overclocker, you might have several hundred CPUs that you need to bin. And one of the sort of most common binning techniques is to just bin CPUs based on their vid tables. So basically, binning for CPUs that have low vid voltages, because generally, like, there's sort of four kinds of CPUs that you can end up with, right? So, and if we consider like vid voltage and sub-zero, so liquid nitrogen overclocking behavior, so you'll have like low vid CPUs with good scaling on LN2. Then you have low vid CPU, and like if you have a low vid good scaling CPU, those things are just amazing. That's like the best kind of CPU you could ever hope for because it does high frequencies at low voltages and it also scales well with temperature. But then you have low vid bad scaling CPUs. So these are CPUs that at ambient are still really, really good. But on liquid nitrogen, they'll generally just stop scaling with voltage at like some relatively low voltage. So they'll max out at like not necessarily at a low frequency, but they're not going to be like a world record class chip. If anything, they're probably like they might even end up being slightly worse than like an average CPU with average scaling. So you can get those kinds of low vid CPUs, and then you get the high vid CPUs where you have, you know, CPUs that need a ton of voltage to hit like any frequency at ambient. And those can also come in two flavors of bad scaling or good scaling. Now, a high vid CPU with good scaling can be better than a low vid CPU with bad scaling. But a lot of, like, it's still never, like, generally it's not going to compare to a CPU that is low vid and also, you know, good scaling. So a high vid CPU with good scaling is kind of like, it's, you know, it's better than a CPU that doesn't scale properly, but it's still probably not going to be world record class. It'll certainly get, like, good results potentially. And then you have the high vid CPUs with bad scaling, and those are just terrible across the board. Those just, yeah, they suck at ambient, they suck on liquid nitrogen, they're, you know, just terrible, terrible CPUs. And so because of this behavior, if you have several hundred CPUs to get through, trying to sort through the high vid CPUs to find CPUs that have good scaling is generally not very time effective, right? Because you're going to have tons and tons of CPUs with relatively high vid values. And even if you find some that do have good scaling, they're just not going to beat out a low vid CPU that has good scaling in the vast majority of circumstances. Like, you want a CPU that's really good at ambient and then even better on liquid nitrogen. A CPU that's like below average or average on ambient and then doesn't suck on LN2 is kind of like, like, like it's better than having a CPU that's amazing on, like, it can be better than having a CPU that's amazing at ambient but terrible on liquid nitrogen. But if you're going for world records, you don't really want a CPU. You want the best CPU, not something that's like okay. So because of that, it makes a lot of sense to basically, if you're binning a very large quantity of CPUs, to first just sort them by the vid, because that eliminates all of the CPUs that are almost certainly not going to be world record class. Like, they might not be completely useless, but a lot of them will suck. And so why waste your time with that when you could just start with the CPUs that actually have the highest potential to actually be really, really good? And so that's why we have the SP rating, because if you have hundreds of CPUs to get through and you need to quickly check the vid voltages, it's easier to just, look at a SP number like 81 or 90 than go through like the vid table, which I think on some CPUs you had to even go like all the way to Windows to actually get the vid reading. So Asus has basically added this feature so that, if you're binning CPUs, you can just sort through them very, very quickly. So yeah, that's what the SP rating is just a simplified representation of a CPU's vid voltage. Now let's take a look at some of the statistics, including also my 12600KF for comparison with my 12900K. So my 12900K is a 90 P-core 65 E-core, which is below average for the P-cores. For comparison, here's my 12600KF, and the 83 P-cores are actually, that's above average for a 12600K or 12600KF. The E-cores, I don't know, I don't care, and the SP rating overall is slightly above average for a 12600K based on the binning statistics that I have access to. So let's take a look at the statistics that I have access to. So the data was collected by Bullshooter, Sergman, Dagunzi, and QuickMew, who are all competitive overclockers from Germany, and they had access to 276 12900Ks, as well as 294 12600Ks. So the average overall rating for the 12900Ks was 85. So my chip and also I should mention that this data comes from pretty close to the launch of the 12th gen CPUs. And the reason that's significant is I have heard that at least for 12900Ks, the SP ratings have been crawling downwards, as Intel is probably holding back a lot of the really good CPUs or holding back a lot of the better CPUs, I should say, in order to make 12900KS CPUs. So yeah, 12900Ks have been slowly, like, on average, they have been getting worse. So this data might not be representative of what's currently available in stores. So yeah, just sort of keep that in mind. Anyway, the average overall rating for these 276 CPUs was 85. The absolute best P-core rating that they found amongst all of these chips was 110, which, yeah, so that's like 20 points above what I have, which is great. Unfortunately, I don't know how the SP ratings correlate to like frequencies on ambient or liquid nitrogen. The data doesn't include that. It only includes SP ratings because it is just, like the sort of the first pass of the binning process is what this data is. And then the further testing data, I don't have access to that. Anyway, which I'm not even sure if that even exists as a spreadsheet, like any further, more detailed test data. Anyway, the absolute worst P-cores that they found amongst these 276 12900Ks had an SP rating of 84, which is terrible, right? Like my CPU tops out in Prime 95 small FFTs with a custom water cooling loop and liquid metal at 5.15 gigahertz. So a SP rating of 84, if I had to guess, that would top out at 5.1, maybe less, right? With the same amount of cooling, same amount of voltage, it would actually probably might even need more voltage. So I would expect an SP rating of 84 to actually be, like sub 5.1 gigahertz for maxed out AVX workloads. Even if you have a very good cooling system for them. So yeah, 12900Ks can they can be quite bad. Now, the 12600K, we have with the 12600. Oh, and I guess I should mention that. So the thing is, when they were doing this binning, they went through all 276 CPUs, or, well, they went through a chunk of the 276 CPUs without checking the P-core ratings specifically. So they only check the P-cores specifically at random for 150 CPUs. Like the best CPUs that they found in the sort of first overall SP rating pass, they checked those for like, P-core, and that's where this like 110 SP rating CPU comes from, is actually from the from the CPUs that aren't part of this average P-core statistic, because yeah, they weren't checking all of the CPU, like the P cores on all of the CPUs. So anyway, but they did check all of the, but this is 150 random CPUs that were checked for the P core SP rating, and those got a 93 on average. So yeah, my 12900K is, based on this average of 150 chips, mine is 3 points below average for its P core rating. Anyway, let's talk about the 12600K. So 294 samples, overall average average SP rating of 71. So my CPU with a 76 is slightly above average by like 5 points. The average P-core, average P-core specific rating out of 248 random CPUs was 78. So yeah, my CPU is like 5 points above average on that. The absolute best P-core that they found amongst all 294 12600Ks is a SP rating of 97, and the worst is an SP rating of 58. So yeah, there's a lot larger. There's a bigger range of what you can get with 12600Ks with 12600K P cores, because 12600Ks don't have as hard a stock spec, right? Like the main limiting factor on what Intel will make into a 12900K is how many 12900Ks is Intel selling, and then how can the CPU even reach the spec of a 12900K? That's sort of the two criteria, and so that sets sort of like you can't really have a 12900K with a SP rating of 58, because it probably wouldn't be able to do stock, right? Like it literally wouldn't run the stock specification for a 12900K. So there's a lower limit for how bad the SP rating of a 12900K can be. But I'm not sure if that's actually 84. This probably isn't a large enough sample size of CPUs, and maybe over time the SP rate, like Intel figures out some way to get even worse SP rating CPUs to still do 12900K specs. Anyway, so 12600Ks have a lot more range, and the best 12600K they found was not as good as the best 12900K they found, which kind of makes sense, because I guess it's kind of unlikely that you would have a 12600K that's as, like, a 12600K is a binning reject of the 12900K, so it kind of makes sense that you wouldn't get one that's, significantly, like, that's better than a 12900K, than a good 12900K, because, like, this is a lot better than, like, my 12900K for the P cores, but yeah, anyway, I did go ahead and make some graphs of these statistics, so let's take a look at those, and we're going to start with the graph for the 12900K, which, you'll notice it's very lopsided, right? Like, a lot of the, but yeah, so like it is very, very lopsided. Mind you, again, this is from launch, so if anything, this upper portion of the graph on current retail CPUs is probably gone. As it, like, CPUs in this range are probably being converted into 12900 KS chips, and so yeah, this right here you're not gonna have. So like basically more 12900Ks are going to be falling into this range these days. Yeah, and so my 12900K is like over here. It's not actually part of this binning session, but like, yeah, it's it's not super uncommon apparently, but actually this is probably like a top, like 7% of CPUs probably. Like obviously you'd need a, it doesn't make sense that like there's only 789s and then there's 1888s. That's just not a large enough sample size, but we can see a trend. 12900Ks are lopsided, right? A lot of 12900Ks are relatively bad, which makes sense because again, the 12900K's main thing is like meeting spec, and so yeah. Anyway, oh, and if you have a CPU that's like more than, well, if you have 108 SP rating or 110, anything close to 110 SP rating, that's like a top 1% CPU. Yeah, because they only found one, and like they didn't even find, and this is from the 150 random samples, not from the, because this is P-core data, so. Yeah, this isn't data for the full 276 12900Ks that they tested. Anyway, let's move on to the 12600K graph, which looks like this, and much less lopsided, which makes sense because the 12600K is much less, difficult to meet the spec, right? Um, so yeah, like 12900Ks are pretty relatively consistent compared to 12600Ks, but a lot of them aren't really like, a lot of 12900Ks aren't that great. On the other hand, 12600Ks, I mean, a lot of them still aren't great, right? Like literally by definition, half of these CPUs have to be below average. But yeah, the graph isn't as lopsided as it is for the 12900K. But getting a 97 is like evidently even less likely than, like getting a really good 12600K is, well, actually, no, we can't say that, but like getting a 95, like the top 1% 12600Ks are like high 90s by SP rating. So, yeah. And my CPU is, what was it? Let's close this, close that. Yeah, mine's a P-core rating of 83, so mine is in like the top 20%, I think. Like at a glance, I want to say that's like top 20% because we've got all of this up here, which is like nothing, and then we've got like 5%, 5%, 6%, which I think these would actually probably average like again, if you had a larger sample size, I imagine we wouldn't have these random spikes in this unless. Nah, it doesn't make a lot of sense to me that you would have these random like, like this being 5% and then 2% and then 6%. That doesn't really make a lot of sense. I think if you had like thousands of CPUs, this would be very smooth. We wouldn't have these random spikes in here. So yeah, I'd say my CPU is probably like my 12600K is probably something like top 20, top 25%. Whereas my 12900K is in the bottom 50%. Yeah, because that right there, like this right here is already like 35% of CPUs that were tested. Add this to that, which is, well, add this, and we're in the 40%, 49%. Yeah, so mine's like 40, yeah, bottom 50%. So mine is slightly below average. But yeah, with the 12600Ks, I got a little bit more lucky, so I have a top 25%. Anyway, so 12600Ks, I don't believe there's anything going on with them and like their SP ratings getting gradually worse over time, whereas 12900Ks, 12900KS exists, so that's kind of a concern there. Anyway, hopefully you find this somewhat useful and interesting. I mean, it's not really all that, like, mostly interesting, because unfortunately, I don't know what kind of frequencies 108 SP rating gets you. I would imagine that a 108 SP rating with a really, really good water cooling system probably hits like 5.2 to something between like probably 5.25 to 5.3 gigahertz in Prime 95 small FFTs with AVX2 is what I would suspect such a, really high SP rating 12900K would do if you have enough cooling. For compare, so like 150 megahertz more than what mine does in that same workload. And then at the bottom, because I think it's impossible that there's a CPU that does 5.4 gigahertz for Prime 95. Like there are CPUs that do 5.4, 5.5 for Cinebench, but 5.4 for Prime 95 is like no. I refuse to believe that is possible. That would have to be like an SP rating of 120. Maybe there's a 12900KS that can do that, but like that's going to be like a top 1% 12900KS. It's going to be the top percentage of top percentage CPUs at that point. So Yeah, but again, the frequencies are just a guess. Like the only thing I know for sure is that my 90 gets 5.15 in Prime 95. And the SP rating is I don't know, I'm not sure that I mentioned this. The SP rating at ambient is actually relatively accurate. So if you have like a low SP rating at and you're on like water cooling or air cooling, it's pretty much guaranteed that the CPU is just going to suck. If you have a high SP rating, it's pretty much guaranteed that it's going to be good. It's only on like when you add in liquid nitrogen that you get those CPUs where it's like, oh, it was really good at ambient, but then like because the thing is the SP rating is based off the vid table, and the vid table is set by Intel for ambient operation, right? Like they're configuring the vid table for like air cooling and water cooling. So the vid table is relatively accurate for frequency, like rather accurate for frequency behavior at ambient, and then on sub-zero temperatures, it kind of breaks down because you do get those CPUs where it's like, well, it was great at ambient, but it's terrible on liquid nitrogen. So, yeah. Anyway, that's it for the video. Big thank you to QuickMew for sharing the binning data with me because yeah, this is like really like I find this really interesting because a lot of the time, well, you don't get proper information on like what's a good 12900K, what's a good 12600K, right? Like, and people who have average CPUs don't post about their very average overclocks, right? Because who cares about your average overclock? So, anyway, yeah, that's it for the video. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. Both Patreon and Teespring help out immensely with running the channel, so it would be much appreciated if you check them out. And that's it for the video, so thank you for watching, and goodbye.